we're given the graph of a function y equals f of x, and then asked to sketch the graph of y equals minus 3 times f of 2x plus 1. So we're going to transform this graph into another one. What I want you to do right now is pause the video and just write down the transformations that are going to happen without worrying about what order they're going to happen in or even by how much they're going to happen by. Just try to write down the correct transformations. Okay, so I want to talk about the transformations, and you could have written these down in any order to answer what I just asked. In a moment, we'll talk about putting them in the correct order. I'm hoping that you identified a horizontal compression coming from that 2 times x in there. I like to think about that like the x's are happening twice as fast as they used to, so they're going to get squished in the horizontal direction. I hope that you saw a vertical stretch, a vertical reflection, and a vertical shift up. Okay, now we need to talk about the order those things happen in. And if we go by the order your author suggests, we'd look for any horizontal shifts left or right. Well, I'm not adding or subtracting on the inside of the function, so there is no horizontal shift left or right. Then next we'd look for stretching or shrinking, right? There's stretches or compressions in any of the directions. And we have 2 of those. All right, so when I'm thinking about doing this in the right order, I'm going to do the horizontal things first and then the vertical things. It doesn't matter, because if I squish this way and then squish this way, it's the same thing as doing it backwards. Now we have a squish and a stretch, and we could do them in either order, but I'm always going to go inside, outside, because that's the way I like to think about them. Then your author tells us to do all the reflections, so we will do that reflection with that minus out front, so flipping our graph over after we've compressed and stretched it. And then lastly, we'll shift things up 1 unit. All right, so this horizontal compression is by a factor of 2. So all of my x values are going to get squished. So I'm going to do these transformations one by one. So I'm just going to look at the x-coordinates, and every time I see an x-coordinate, I'm going to squish it by a factor of 2, so I'm going to divide it by 2. So I have 1, 2, 3, 4, 5, that's the point minus 6. That point's going to have to squish over to minus 3. This point at minus 2 is going to squish over to where its x-coordinate is a minus 1. This point here is at positive 2, squishes over to positive 1. And then finally, let's see, 1, 2, 3, 4, that's going to squish over to 2. And if I just did that much, just the horizontal compression, my function would look like this. And so what I've really kind of drawn in red and dashed in there would be the graph of y equals f of 2 times x. That's all I've done so far. All right, so now I want to imagine that I take that and I do my vertical stretch by a factor of 3. So I'm going to take all of the y values and multiply them by 3. So this first y value at minus 1, I multiply by 3, so that's going to stretch down to minus 3. 1, 2, 3. This point's at positive 1. We'll go up to positive 3. 1, 2, already at 1. 1, 2, 3. So will this one. And then this point will stretch up till I'm at 6. So 1, 2, 3, 4, 5, and 6. So in this very faint marker that I hope is showing up on the video, and it looks like it is, this would be the graph of y equals 3 times f of 2x. So now I'm to the point where I want to do that vertical reflection, that reflection over the x-axis. And that's coming from that minus out front. All of my y values are literally going to change signs. So this point was at minus 3, and now it's going to flip over and be at positive 3. This point at positive 3 is going to flip down and be at minus 3. Same thing at this one. And this point all the way up at 6, now I'll be down at minus 6. Sketch in the function, and it should look just like the lime green one, but flipped over. And this would be the graph of y equals minus 3 times f of 2x. And now, all I have to do is imagine what happens when I add 1. All of my points are going to shift up 1 unit. And there's my final answer. Y equals minus 3 times f of 2x plus 1. You can do this in fewer steps, right? You could imagine finding where these points go after all of the transformations and draw that final picture. If you want to, though, you can always draw some help along the way, right? You can do this in steps if it helps.